Okay, welcome back to another one. We're looking at volume right now. So we're taking a look at the volume of a rectangular prism. So if you were think about the last video that we watched, we said that the volume is equal to the area of the base times the height. Now, if we think back, the area of a rectangle is length times width. So all we're going to do when we're looking at the volume of a rectangular prism is calculate the length times the width times the height. Now you notice there's three measurements. So if we multiply the width times the height times the length, it's not really going to change anything that much. So let's go in here. We're going to go take a look at this one right here. So if we're trying to calculate the volume of this rectangular prism, we're going to go with our equation first, or our formula. Volume equals length times width times height. And so we're going to pick, I'm just going to go with 7 times 5 times 11. Calculate that 385, and that is in centimeters cubed. Reason being because we have 7 centimeters, 5 centimeters, 11 centimeters. There's 3 of those, and so altogether 385 centimeters. 3 groups of centimeters, centimeters cubed. Let's take a look at a word problem so we can get a little juicier. So a deck of cards fixed into a box shaped like a rectangular prism, so we know what we're calculating. The box has dimensions 6.5 by 9 centimeters by 1.6 centimeters. What is the volume? So you can think about it. Most of us have seen a deck of cards before. We know what it looks like, so we got some measurements there. So we can go volume equals length times width times height, and so that ended up looking kind of weird. Times 6.5 times 9 times 1.6. Let's throw that in the calculator. 6.5 times 9 times 1.6. 1.6 equals 93.6 centimeters. What? Yes, cubed. I know that you answered, so it's okay. It's kind of like Dora, when they're like, swipe or no swiping, you gotta yell. I should have a swiper so you could yell swiper as we go. We'll work that into the next ones. A rectangular swimming pool is to be filled with water. The pool has a constant depth of 2 meters. So some swimming pools, they have like a shallow end and then it goes down to a deep end. This pool is not like that. This pool just has a constant depth. So it's 2 meters deep everywhere. It's 20 meters wide and it's 50 meters long. How much water is in the pool to fill to the top? Same thing as before, right? Volume equals 2 times 20 times 50. So in my head, I can go 2 times 5 is 10, and I'm going to add those other 2 zeros to make 1,000. 2 times 1,000 is 2,000. 2,000 centimeters cubed. Challenge question. Ooh, let's get exciting here. I like a challenge. So how much water is needed to fill the pool within 20 centimeters of the top? So previously, our height was 2 meters, right? But we're taking away 20 centimeters to figure out our new thing, our new volume. So we don't have the same units here though, right? We can't subtract 20 centimeters from 2 meters. We got to get them into the same. So we could convert them either way, except all the rest of these are in meters. So it wouldn't make any sense to change 2 meters into centimeters. So we need to change centimeters into meters. So we're going to go 20 centimeters divided by 100, and that's going to equal 0.2. So remember, if we divide by 100, we could just slide our decimal over 2 spots. So 0.2. So now we got 2 minus 0.2. That is going to give us 1.8 meters. So now we can just redo our same calculation as before. 2 volume equals length times width times height. Let's make a little bit more space here. Okay, so we had 20 times 50. We had this part, which we didn't change, but we changed our 2 to, we got rid of 0.2, switch into 1.8 times 1.8. So again, 20 times 50 is 1,000. We did that up here, times 1.8. So let's see, 1.8 times 1,000. Oh my gosh, if you calculated that with me, 1.8 times 1,000 is 1,800. 1,800 what? Meters cubed, or cubic meters. That's how much water is inside of it. So you would have, that's a lot of water. That's a lot of water, more than a bathtub. Extra challenge question. How much water could you fit in your own personal bathtub that you have at home? Try it out. Let me know what you get. Some bathtubs are massive. Some bathtubs are tiny. Those little RV mat bathtubs, save some water there. Think about how much water do you have in your bathtub. All right, so if you want a challenge question on that, how much water, how much volume of water do you normally put in when you have a bath, if you have a bath? Okay, that's it for today. We will come at you again with looking at the volume of triangular prisms, but that's it for now. So, as always, take care of yourselves. We miss you, and we'll see you later.